This is GCSE Waves lesson 12, and what we're going to do in this one is talk about, first of all, a concave lens, which is a diverging lens, and the lens diagram that's produced. Then we're going to move on and do some examination questions. So a concave lens will always give you the same type of image, so the object position isn't important. It doesn't matter where it is. It could be greater than 2f, at 2f, between f and 2f in this instant, at f, or closer than f. Obviously, with convex diagrams, the converging lens that we did in the previous video, there were 5 different types of images produced. This is just one. Slightly different diagram, so it's parallel to the principal axis. Once it gets to the diverging lens, it diverges away from the original path that it takes, like this. And then what you do, you trace it back as if it came through f, like that, with a dashed line. So dashed line means that it's a virtual construction line. We're going to get a virtual image because it's on the same side as the object. Second ray goes straight through the optical centre undeviated, as in previous diagrams, and where the two construction rays meet is where we get the image. So description of that image, using keywords. It's upright because it's in the same orientation as the object. It's diminished because it's smaller, and it's virtual because it's on the same side of the lens. And it's the same type of image for all object positions. Alright, let's move on and do some questions. Remember to pause for each question, write down your answers, and then I'll take through the answers. So the diagrams below show some piece of glass. Which one, A, B, C or D, is a converging lens? So converging lens is a convex lens, which is B, and a diverging lens is a concave lens, which is D. A is just a rectangular piece of glass, and C is a mirror. So I'm going to pause and do this one. So complete the diagram below to show what happens to the rays of light when they pass through B. B is a converging lens or a convex lens, so the rays of light are going to converge onto a point which we call the focus point. So try and do this one. Not very good at this. There we go. And this one. There we go. Something like that. And remember to draw the directional arrows. You could even label that F for the focus point if you wish. And just a bit extra, remember that is focal length. Alright, let's move on. So similar questions to the one that we've just done, so it should be really straightforward. So the diagram shows 2 parallel rays of light, a lens and its axis. Complete the diagram. So it's the exact same. Just extend that out a little bit to the centre. Exact same as what we've just done, so you need a focal point. And then just draw your lines in with a ruler. And some directional arrows. So name the point where the rays come together. Focus point. What word can be used to describe this type of lens? Well, it's a convex lens. You could also say converging. Next one. Right, I'm going to pause and do this. So the diagram shows 2 parallel rays of light, the lens and its axis. Which point A, B, C or D shows the focal point for this diagram? So this one's going to be point A, because this is a concave lens, which is a diverging lens, which means that the light, just put that in the centre, will move outwards, and then you get dashed lines that come back to the focal point A. It's a virtual focus point. Explain your answer B1. So probably something on the lines of it's a diverging lens. And you'll get a virtual focus point. What word can be used to describe the lens? We just said that's diverging or concave. Alright, next one. So I'm going to pause and try this one. So 4 pieces of apparatus are shown below. So you've got a converging lens, diverging lens, glass block, and a plane mirror. So each box below contains a piece of apparatus. The lines show how light rays going into and out of the boxes. So what we need to do is draw the correct piece of glass or mirror in each box. Okay, so the first one is a reflection, so that's just going to be a plane mirror. Q, so they're diverging out, so that's a diverging lens. Just sketch that one in there. R is the refraction, which we did a couple of lessons ago. So just draw your block in there. That last one, so lights converging together. So that's obviously a converging lens. Hopefully that one went okay. Let's move on. So this is a camera. If you remember what I talked about in the previous lesson, I said that you need to know the type of image that's produced by a camera anyway, and we do that using RID. Right, so complete the ray diagram. As you can see, 4 marks. So you draw a ray of light I'll try to do this. It's quite tricky drawing on this. So ray of light parallel to the axis, and then refract through F. And then the second one goes straight through the optical centre, undeviated. So try this one. Rubbish. Let's try again. That's as close as I can get it. Should obviously go through the centre. So that ray diagram is worth 4 marks. So state 2 words to describe the nature of the image. So the image is here. So it should be real, inverted, diminished. We should know that anyway. Then just write them in. So real, inverted. You could write diminished as well. But as you can see, that's like 6 marks just for that. So if you learn the diagrams, easy marks to pick up. 6 marks is probably the difference between an entire grade. Let's do the next one. So the diagram shows a converging lens uses a magnifying glass. So this one actually tells you what the what type of diagram we should be drawing. On the diagram, use a ruler to draw 2 rays from the top of the object, which show how and where the image is formed. So obviously if you've got a ruler, this is much easier. So parallel to the axis, refract it through F, like so. Draw some directional arrows on there. Then the second one straight through the optical centre. Something like that. And then we just need to trace them back. Like I said before, this is much easier with a ruler. They should trace back somewhere there. Alright, let's look at the next question. So the next question is asking you to calculate the magnification. Now these equations typically aren't given unless you're on foundation. I don't think so anyway, I'm not sure. This is one that's on, it might be on the date sheet, I'm not sure. But it's just image over object. So calculate magnification. So what you should do is go back to your diagram. You can either measure the image height and the object height with a ruler and then just divide them in centimetres, or you could count the number of squares. You know, so mine's somewhere here. Measure that with your ruler, measure the object, and then divide them. I think on the mark scheme it's around 3 or 2.8 or something. But you will get a little bit of range to count for any little errors in your diagram. So that's a good thing. So let's say that's around 3 times. So it says a camera also uses a converging lens to form an image. Describe how the image formed by the lens in a camera is different from the image formed by the lens in a magnifying glass. So the magnifying glass diagram you've just done, so you can actually see that diagram. So that was, I'll just call it mag glass. So that was upright, virtual, and magnified. So this is an example of the type of question where I said that you just need to know what type of image is produced by a camera or the human eye. And remember, we do that as RID. So you could simply state that a camera image is real, inverted, finished, which is basically the complete opposite. All right, so remember that is what we need to know of cameras and the human eye. Let's try one more. So last question. There's two parts to this question, but I've only got the first part on. The second part asks you what type of image is produced, and it's also worth 3 marks. So this is another 6-mark question. So let's have a look at this one after you've done it. So the diagram shows an object located vertically on a principal axis of a diverging lens. So a lot of people might make a mistake there. They'll assume it's a converging lens. They've drawn the lens really, really small. So you have to be really careful. It says a student looks through the lens and can see the image of an object. So using a pencil and ruler, draw construction lines on the diagram. Show how light from the object enters the student eye and the size and position of the image. So I'll try my best to draw this one. So straight across. And then remember, it's got to diverge as if it comes from F because it's a diverging lens. So basically what you need to do is something like this. But obviously it should be... that's not good for this. It should be dashed. I'll draw it dashed. But with a ruler, it's obviously more straightforward. So you should have a dashed line that looks like this, and then a solid construction line that comes out after. Make sure you draw directional arrows on there. And then the second construction line just goes through the optical centre undeviated.